Okay, let's take a look at solving quadratic equations by using the quadratic formula. So sometimes we can factor our trinomial, we can factor our equation to figure out what our zeros are. Remember, they can be called zeros or x-intercepts or roots. They all mean the same thing, basically the solutions to the equation. Now sometimes it won't be possible, or sometimes it'll just be very difficult to factor our trinomial. So we can also use the quadratic formula to solve these questions. Now the quadratic formula will always work. It will always give you the correct answer if you use it properly, of course. So this can sometimes be useful instead of using factoring, because factoring is not always possible. Now, similar to when we solve with factoring, we have to have a standard form equation, so all of our terms on one side with 0 on the other side, and then we can find our roots or the x-intercepts by using the quadratic formula. So our first step, so if we do this question here, same as before, we want all of our terms on one side of the equation. So 5v squared plus 2v minus 135 is equal to 0. Now I'm looking at this, and let's say I want to factor it. I'd have to common factor first. I can't common factor out of 5, so I'd have to use decomposition, and that'll get really messy. So what I'd like to do is use the quadratic formula, because I know that will always work. So looking at this, the first term, or the first coefficient, remember, is your a value. So this means a is 5. The middle coefficient is your b value, b is 2, and then the last term, c, is negative 135. So please make sure you take a look at the signs in front. Those are very important. All right, so to figure out what x is, x equals negative b. So if b is positive 2, negative b will be negative 2, plus or minus, because remember, we can have two different answers here, two different roots, the square root of. Now remember to draw that all the way across, okay? Don't have a lazy square root sign that goes only over top of part of this. B squared would be 2 squared minus 4 times a, which is 5, times c, which is minus 135. Now the whole thing, the whole right side, is divided by 2a, 2 times a, so 2 times 5. So keep in mind that whole thing is divided, okay, not just the radical there. All right, so now we can simplify this a little bit. Now, we have to simplify under the radical sign first, and you don't really have to show any additional steps for that. You can just figure out what it is. All right, so I had to pause it there to type in my numbers. So underneath our radical sign, we'll now have the square root of 2,704, and that whole thing is divided by 2 times 5 is 10. All right, so further simplifying it, next thing I can do is I can figure out what the square root of 2,704 is. Now, in this case, it does work out to be a nice number. It works out to be positive 52. Now, in the case, we'll see a little bit later on, perhaps in class, that won't work out to be a perfect square root all the times. So we'll have to reduce it just like we would reduce a radical last week. All right, so negative 2 plus or minus 52 divided by 10. So at this point, I'm going to split up my solution. I'm going to have two different answers, because I can either add 52 or I can subtract 52. So for my first solution, I'm going to take negative 2 and add 52. Doesn't matter which one you start with. You can subtract first if you like, and then divide it by 10. So that'll be 50 divided by 10. X equals 5 is my first solution. Or remember, we can also subtract 52. So x equals, we got negative 2 subtract 52 over 10. So negative 2 subtract 52 will give us minus 54, negative 54. Now when you divide that by 10, you would get negative 5.4, or I prefer to leave that as a fraction. Negative 27 over 5 is how I'd prefer to see that. But again, like if it works out to be a perfect or an exact decimal answer, that is acceptable. So 54 divided by 10, all right, that would give you negative 5.4. That would be acceptable, but fractions are always good to have as well. All right, so for this one here, we already have a standard form equation. We have 0 on the other side. So we're good to go to use the quadratic formula here. So my a value is 1. Remember, x squared has a coefficient of 1. Our b value is -2. Our c value is 3. So I can go ahead and use the quadratic formula. X equals, now negative b, if b is -2, and I want negative b, that would actually turn into +2, plus or minus square root of, so we got -2, which is b squared, minus 4ac. Now, note how I have -2 in brackets, because this would give us +4, and that's what -2 squared is. If you don't have the brackets, I can't really erase it right now without erasing anything else, but if you write it as -2 squared, that is actually -4, because order of operations says you do the exponent first, and then it would become negative. So please write your negatives in brackets if there's an exponent, and then 2 times 1 in my denominator, 2a. All right, so let's see what happens here. Underneath my radical sign, oh, forgot a bracket there. So I'll have 4 minus 12 is what I get. 4 minus 12 is -8, and then divide by 2. Now at this point, you can type in the square root of -8 into your calculator, and you'll see that it doesn't exist. You actually cannot square root a negative number. So what this means is there is no solution. You can't actually figure this one out. You can't solve it. There's no value of x, which would make the left-hand side 0. Now, what would this look like graphically? So remember that what we're finding here are really the x-intercepts. So if I draw myself a little grid here, we've seen before that a parabola can cross the x-axis twice and have 2 x-intercepts. Or it can maybe touch the axis once and have 1 x-intercept. So what we actually have here are no x-intercepts. So 2 ways that this could look. It could be a parabola above the x-axis and then going upwards as well. So you see that this would never cross the x-axis. Or it could be a parabola below the x-axis, but then it would be traveling downwards. So again, no solution because it would not cross the x-axis.